All right, so shall we start, right? I can't see any attendees, so yeah. We'll just wait for 2 minutes, Anurag sir, and then we'll continue with itself. All right?
Okay, all right.
All right. So we've got a confirmation for being live. All right. Sure. Okay. A very good afternoon, everyone. I believe everyone is doing really good. I hope everyone is doing well. My name is Rohit Thakur. I am the host for today's webinar. This is a series of webinars that we conduct every Friday, and we do it from 4 to 5. We take some interesting sessions, some interesting topics from the field of artificial intelligence and machine learning. And there are professors who come across, professors from different organizations who devote their time for over this period, and they talk about what is happening in the world of AI or data sciences itself. So people who have not attended our previous session, they can definitely go through our YouTube channel, and they could find previous sessions, and these are very interesting sessions where we've had very interesting speakers on different topics from health sciences, the importance of health sciences, the importance of AI in health sciences, or the importance of data in neural networks, deep learning. We have had enormous discussions about these topics. Similarly, talking about today, we have brought back Professor Anurag. We have brought back, he's taken a previous session as well. The people who have not taken his session previously, they can definitely see his session from one of our YouTube videos. Talking about today, he is going to be discussing, he's going to be giving insights about convolutional neural networks, Alzheimer's disease, classification from magnetic resonance and brain images, right? Talking about Professor Anurag, right? He's one of the he's the assistant professor at Yogananda School of Artificial Intelligence, Computer Science and Data Sciences. That is a faculty of engineering and technology in Shoolini University, Solani, Himachal Pradesh. Talking about Mr. Professor Rana, he's a researcher in the field of artificial intelligence, deep learning, and soft computing. He has filed 3 patents, and he's one of the members of IEEE, IEENG, and National Institute of Technical Training and Skill Development. So this gives me immense pleasure to welcome Professor Anurag. Yeah. So yeah, hi, Professor. You can continue itself, and we would be very happy to take questions from all of the attendees, and we would really want people to come up with all the questions, all the doubts they have regarding neural networks. They want to have understanding of deep learning, and Professor Anurag will be there to answer those questions. But it would be really great if that most of the questions are asked on the later part of the webinar itself. That gives us that would help Anurag sir also to complete his session, and we'll take your questions after once the session is completed. So you can continue, Professor Anurag, and I'll just all yours.
Okay.
Thank you.
Thank you, Rohit. As Rohit told you that today's session that is on the CNN-based Alzheimer disease classification from the MRI brain images. As you all know that the Alzheimer disease is a progressive neurologic disorder that occurs and cause the brain to shrink and the brain cell to die. Alzheimer's disease is the most common cause of the dementia and the continuous decline in thinking, behavior, and the social skills that affect a person's ability to function independently. And there are approximately 5.8 million people in the USA age 65 and older live with Alzheimer's disease, and of other 80% are 75-year-old and older, and out of the approximately 50 million people worldwide with dementia, between the 60 to 70% are esteemed to have Alzheimer's disease. And here we will discuss the few of the concepts. In this case, we know about the introduction, the method, the result, and we will discuss one of the research paper on the in which they will discuss what is the Alzheimer and how we use the CNN for how we classify the MRI images. So let's start with the Alzheimer. That Alzheimer disease, that is the most common form of the dementia in the neurodegenerative brain order that has currently no cure for it, and hence early diagnosis of such disease using computer-aided system is subject of the great important and extensive research among the researchers. Nowadays, the deep learning, or particularly CNN, is getting more attention due to the state-of-art performance in the variety of the computer vision, such as visual object classification, detection, and segmentation, and the several recent studies that have used the brain MRI scan and the deep learning have shown the promising result for the diagnosis of Alzheimer. I'll be talking about the Alzheimer disease, Alzheimer that become such disease for which currently there is no cure or a treatment that stop its progressions. Therefore, we require the robust and accurate method for the early diagnosis and the diagnosis of the heterogeneous data. It can be certainly exhausting and to the manual compare, visualize, and analyze this data. So we are using the deep learning technique, and in the deep learning technique, we are using the classification method for how to classify. But the main problem and the solution that in the CNN that we are using for what and how we use the early diagnosis, and what are the 7 Alzheimer facts that we are facing, and what are the current solutions. So first of all, we are talking about the 7 Alzheimer facts. In the if we are talking about that, it is estimated the amount of cost of AD maybe that is 1.2 trillion. The most of the common form of the dementia among the older people is the Alzheimer disease, and it have the having heart disease, that is the risk of the getting AD. Sometimes the USA developer Alzheimer disease is every 60 seconds. Almost 2/3 of the American with the Alzheimer disease are the women's. And if we are talking that the various medical tests exhausting to the manual compare and the analyze data, and after that we have used the CNN that is used that have performed well in the medical field for the tasks such as visual object recognitions, detections, and the segmentation. There are a few of the limitations for the current CNN solutions. The first one, the limitation that we require the huge amount of annotated data. We require the huge amount of the computational resources. We require the careful and the tedious tuning and the hyperparameter optimal tuning. And the improvement that there is good transfer learning. We have the last time for the computations, and in the new approach we are focused on the first one, that is the transfer learning. That is the machine learning method where the model developed for the task and it is used as the starting point for the model on the second task. The training CNN take a week versus the pre-trained CNN take much lesser time, typically few hours. In this paper that in today's session we will discuss, that is the BGG16 is taken as the base model for apply transfer learning. And in the BGG16 there are the 16 network that is built by the Oxford Visual Geometric Group, and it participated in the ImageNet and computation in the ILSR VR 2014, and it is one of the first architecture that is explored the network depth by the to the 16 layer using a small 3x3 convolutional filter. And if you're talking about the few of the related works that happen, that the medical imaging data that is come in the various modalities such as the structural or the functional MRI, diffusion tensors imaging, position emission tomography, that is the PET scan, or we can say that is the CT scan. That all these kind of the data that is happen, we have the different type of the images with different type of the data, and there can be some drawback by using the artificial neural network for image classification tasks, because the ANN is usually seen that to yield the high accuracy, and it requires the high convergence time period as described. But as we say that the majority of the early Alzheimer diseases diagnosis method that is based on the classification of the feature extraction from the brain images, where features are supposed to the accurate and capture the AD-related variations of the anatomical brain structure, and these features are usually then fed to the classical machine learning algorithms such as the sport vector machine, random forest classifier, or feed-forward neural network for the classifications. The method that consists the two fundamental states. The one is that is the feature selection stage, and here they are using the selecting the most of the informative features that is using to regularize logistic regression, and the classification stage where they are applied semi-supervised low density separation that is commonly known as the LDS, that is used to produce the final predictions. If we're talking about the methodology that we are using in the CNN, that is first of all, we have the component of the CNN model. After building the component of the CNN model, we are going for the data collections. After collecting the data, we are move ahead for the Alzheimer classification. We are developing one of the mathematical model, and on the basis of that particular mathematical model, we are classify the images that data that we are collected. After that, we are moved for the selecting the most informative MRI slice based on the entropy. And after that, we are creating a model and train that model and test on that particular samples. And after that, we are classifying that particular image using the transfer learning. That is the advanced feature that is used in this particular model. Here is the building component of a convolutional neural network in the CNN layer. That is the core building block of a CNN. Here is the input volume. Here is the filter weight, weight 1, and there is the output volume. And here we are divided that into the 2 plus minus 2 plus 1 minus 2 plus 1 minus 2 minus 2, and that is the mathematical model for the CNN. After that, the next concept that we are using in that is the max pooling. Max pooling is the aggregation operations that extract the maximum value, and the main reason for the max pooling is to reduce the size, and we get the average pooling from the using that particular aggregations operation that is known as the max pooling. After that, we are using the dropout regularization, the dropout of the neurons, that is the both hidden and the visible layer in the neural network randomly, and mainly tackle the problem of overfitting in the neural network. If we are talking about the concept of CNN, how the CNN is working, because it is important to understand how the CNN is working. But before that, it is important to understand what is the CNN. Basically, CNN is the special type of the feed-forward ANN, artificial neural network, in which the connectivity pattern between its neuron is inspired by the visual cortex. And the visual cortex encompass a small region of the cell that are the region that is the sensitive to the visual field. And in case of the some certain orientation edges are presented, then only some individual neuron cells get fired inside the brain, such as some neuron respond as and when they are get exposed to the vertical edges. However, the some respond when they are shown into the horizontal or the diagonal edges, which is nothing but the motivation behind the CNN network. It is the CNN network, which is also called as the COVNet, COVNETs, COVNets, that are nothing but the neural network that sharing their parameter and suppose that there is an image which is embodied as a qubit, such as the encompasses the length, width, and height. And here the dimension of the images are represented by the red, green, blue channel that is represented in the CNN network. Now, if we are talking about the mathematically, it could be understood as follows: that the convolutional layer that encompasses a set of the learnable filters, such as the each filter embrace the small width, height, as well as the depth, as that of the provide the input volume. And if we suppose that we want to run the convolutions over the image that comprise 34 by 34 by the 3 dimensions, such that image filter can be used as A into 3, and here can be any of the above 3, 5, 7, etc. And it must be small comparison to the dimensions of the images. And the each filter that can slide all the input volume during the forward pass. It's like the step-by-step calling each individual step as a style that encompasses the volume of 2 or 3 or 4 or higher dimensional image, followed by the calculating dot product in the between the filter, that weight, and the patch from the input volume. And it will be in the 2-dimensional output for each filter, as and when we slide over the filter, followed by the stacking them together, so as to achieve an output volume to have a similar depth volume as that the number of the filter, and then the neural network learn all the filters. Now we are talking about generally that CNN has the 3 layer, which as follows as the input, that is convolutional, that to the ReLU layer and the pooling layer. First of all, we are talking about the input. If the image consists of the 32 width, 32 height, and contains their 3 RGB channel, then it holds the raw pixel 32 into 32 into 3, the value of an image. And the convolution, it is a compute the outcome of those neurons which are associated with the input local region, such that the each neurons will be calculated a dot product in between the weight and the a small region to which they are actually linked to the input volume. And if you're talking about the ReLU layer, that is the it is specifically used to apply an activation function element wise, like as a max thresholding at the 0, and it results 32 into 32 into 12, which is related to the unchanged size of the volume. The pooling, this layer is used to perform the downsampling operations along the spatial dimension, that is width or height, that result in the 16 into 16 into 12 volume. And the other thing that is used in the CNN, that is the locally connected, and it can be defined as a regular neural network layer that receives as an input from the preceding layer, followed by the computing the class 4 and the result in a 1-dimension array that has an equal size to that of the number of the classes. And we will start with an input image to which we will apply the multiple features detector, which are also called the filter, to create the feature map that comprise of the convolution layer. And then on the top of that layer, we will apply the rectified linear unit, that is the ReLU, to remove any linearity or increase the non-linearity in our images. After that, we will apply the pooling layer to our convolution layer, so that from every feature map we are creating the full feature map. As the main purpose of the pooling layer is to make sure that we have a spatial invariant in our images. And it also reduces the size of our images, as well as avoid any kind of overfitting in our data. And after that, we will flatten all our pool images into the long vector or a column of all these values, followed by the inputting these values into the ANN. And after that, at last, we will fit it into the local connected layer to achieve the final output. If you're talking about the non-linearity layer that I already discussed, that we are using the rectified linear unit. In that particular this research paper, we are using the ReLU function, that is as a activation ReLU function we are using in this case. And that particular rectified linear unit conversions 6 times faster as comparison to the tangent, hyperbolic, or the sigmoid activation functions, and it convert all the negative input to the zero, and then the neuron that does not get activated. This make it very computational efficient, as the few neurons are activated per time. Here is the mathematical formula to calculate the value. If we are talking about the fully connected layer, that the neuron that is a fully connected layer that have the fully connection to all the activations in the previous layer, and that are fully connected layer are usually appended after the combination of the convolution, max pooling, and dropout layer in the CNN. Here is the diagram. Here we have the two hidden layers. Here is the one input layer and one output layer, and there is the two hidden layer, and these two hidden layer has the four neurons each. Now we are talking about the data collections. That data we are used to obtain the Alzheimer's disease neuroimaging that we are using, that the ADNI, that is Alzheimer's disease neuroimaging initiative, and that ADN was launched in 2003 as a public-private partnership led by the principal investigator, Mr. W. Bennett, MT. Here is the sample of our data set. In our data, there is a class that we are defined. After that, there is a number of male, the number of female, age range, average age, that is the mean square error scoring days, average mean square error scores. These are the data collection, and that is a data pre-processing using the free surface, and free surfer, that is the image analysis tool that which is documented and freely available for the downloads online, and we use that to remove the unnecessary detail of the brain MRI that might cause the poor training of our classification model, choroidal reconstruction, and volumetric segmentations. There are the five process here. These are the five processes. If you are talking the first one, that is the motion correction and conform, and when there are the multiple sources of the volume, and this process will be correct for the minor motion between them and will be average them together. And here is the mathematical concept. We are using the volume 1, volume 2, and volume 1 in the different input volume of the images, and after motion correction the new output volume will be received, and the non-uniform intensity normalization we are using, and that is also called as the N3, or a correct the MRI data by removing the non-uniformity in the intensity of the images. And these are the mathematical formula that is used that initialize the pixel coordinator and to convert the coordinate using the following equations. After the data pre-processing, we are using the intensity normalization, and this particular step correct the fluctuation in the intensity. It scaled the intensity for all the voxels such that the mean intensity of the white matter is 110, and that white matter pathway play an important role in the human brain by connecting the spatially separate area of the CNS that and enabling the rapid and efficient information exchange. After that, that is the skill stripping. That step remove the skull from the normalized image. Here, the selecting the most informative MRI slices that is based on the entropy. Here is the 3D images. After that, the pre-processing, we will get the 2D images. That is, after again the entropy, we will get the top 32 slices of the two-dimensional images. The classification using the transfer learning, but before move ahead for the classification using for machine learning, we have to understand how to build the CNN. Basically, CNN that consists of adding an extra layer, which is called a convolutions that give an eye to the artificial intelligence or a deep learning model, because they are help of it, and can easy to take a 3D frame or images as a input, as opposed to our previous ANN that could only take the input vector and containing the sum of the feature of the information. But here we are going to add at the front of the CNN, which will be able to visualize the image just like a human do. In our data set, we have all the images that is training as well as the test as the set folder, and we are going to train the CNN model on the 4,000 images of the MRI of the human brain, and respectively that present the training set that is followed by the our models, which is the new of the 1,000 of images of the brain images, respectively in the test set, and whichever model was not trained. So we are actually going to build and train CNN to recognize if there is a Alzheimer in this one, or there is a not. For the implementation of the CNN, we are going to use the Jupyter notebook, and we will start with importing the library data pre-processing, followed by building a CNN, training the CNN, and lastly we will make a single prediction, and all the steps that will be carried out in the same way as we did in the artificial neural network. The only difference is that now we are not pre-processing the classic data set, but some images, which is why the data pre-processing is different, and we'll consider doing the two steps. That is, the first step, we will pre-process the training set, and then we will pre-process the test set. In the second part of the CNN building, that we will build the whole architecture of the CNN, and we will initialize the CNN as a sequence of the layer, and then we will add the convolution layer, followed by adding the max pool layer, and then we will add the second convolution layer to make the deep neural network as opposed to the shell of the neural network. And next we will proceed to flattering layer to flatten the result of the convolution and the pooling into the one-dimensional vector, which will become the input of the fully connected neural network, and finally we will connect it all the output layer. And in the next part, that is the third part of the building of the CNN, we will first compile the CNN, then we will train the CNN training set, and then finally we will make a single prediction to test our model in a prediction. That is when we will deploy our CNN to the different images, and one of that is the Alzheimer patient, and one of that is for the normal patient. If we are starting, we are using the Python program or some of this one that we are using. And in that particular case, in the classification of using the transfer learning, that we are using the VGG16, that is the pre-trained or ImageNet data set that is taken as a base model. And after that, we are use the fully connected layer from the base model, that are newly fully connected layer that is added at the end of the base model, in which the first layer that consists of 256 neuron. In the second layer, that is the dropout, with the dropout ratio that is 0.5, means the half of the neuron will output at any instance. So here is the classification that is using the transfer learning. Now we are talking about the creating the training and the test sheet. We are here is the balanced data set, that is approximately more than the 4,000 images that is supposed, and the split into a training and test set, which split the ratio 80% is 80% of the images are used for the training purpose, and rest of the images are used for the validation and the test purpose. Here, if we are talking the accuracy and the result of that particular this updated neural network, the resulting accuracy for the test validation set that came out to be a 95.70%, and the accuracy of the 99.14, 99.30, and 99. That is for the AD versus the CN, that is AD versus the MCI, and that is and the MCI versus the CN classification, respectively, that we are using. Here is the result. That is the formula to calculate the precision. Here is the formula to calculate the recall value. Here is the formula to calculate the F1 value. Here is the classification type that we are using. Here is the class level. Here is the precision value. Here is the recall value. Here is the F1 score. And that is the result. That is the accuracy plot by the three-way. The top left, that is for the AD versus CN, and after that we are using that is in the next way that we are using AD versus MCI. After that we are using the CN versus MCI, that is the bottom right of the corner. Here is the result approaches. There are the different authors, and there are result on that is the three-way of high accuracy, that is 95.73, and as comparison to
Hi, Anurag sir. I believe there is some network issue from your side. Yeah. I just got confirmation from Anurag sir. He'll be joining right away. There is some network issue that he's technical issue that he's facing. So meanwhile, I'll just answer these questions that we've got. Raj is asking, what is the need of using artificial neural networks? So when we talk about, I believe Professor Anurag is going to be the right person to answer that. Talking about artificial neural networks. Neural networks are specifically used like when we talk about understanding certain, like if I talk about when we are trying to replicate certain things artificially, right? So when I say replicate certain things, we have so many devices nowadays who are able to replicate so much of information, right? We have Siri, Alexa, there are so many other things itself, so many such options, like even Google Assistant itself. So by analyzing a data, when they're able to replicate the human behavior, that is where artificial neural networks are used actually. So I hope, Raj, that answers your question. Okay, no confirmation from Raj. So we've got the second question from Raman. He's asking, how can we count the layers in a neural network? So how you can count layers in a neural network? Firstly, the layers of a neural network depends upon the precision, to actual precision, the results that you want. Okay, so it depends, like, see, if you are able to find a result, you are able to replicate a model in your 2 layers, in your 3 layers, that is enough, right? You're good to go with that itself. But when you're not able to find out the results in 3 layers, so what happens is machine is able to create so many of frameworks, right? It creates so many of layers to have the exact replication of your model, or replication of your uh, if I talk about a replication of your algorithms and all. I hope, Raman, that answers your question as well. So we'll wait for Anurag sir. These are the two questions. If people have a few questions related to the I would really like to answer those questions itself. So I hope these two questions that you guys have, that Raman has and the Raj has, I believe they are satisfied with their answers. Okay. And if you guys have any other questions related to neural networks, please type down on the chat. I would be really happy to take those questions as well. All right. So I guess people have only two questions, right? Uh, Feel free, be confident of asking any questions that you have related to neural networks. I'll try to answer those things. So we have Anurag sir back. There was just a technical glitch that he's facing. He just notified me, so he'll be back. He'll take over the remaining of the topic. Yeah, hi Anurag sir, are you able to hear me?
I think
Yeah,
there
I
is
can.
some
I
technical
can.
problem.
Yes, I can see there is certain technical problem. Just let me know if you can continue further itself.
No, that's all for the result. That is the last slide for the CNN. Now it's
Okay.
open for the question.
Okay. Okay. Perfect. Perfect. So I actually there were a few of the questions that people had. I tried to answer those, but I would really like your point of view on those questions as well, so that we have a clear idea about those questions. So we have Raj with us, who's asking what
But
is the
hi,
yeah.
Rohit, your voice is not audible.
All right. All right. Okay. I guess
It's breaking.
yeah, I can understand. This is some technical glitch because as I could see, I can hear your voice quite. So what we can do is, even your voice has been breaking, Anurag sir. You can do one thing. You can read the questions from the chat, and you can take the questions from the chat onwards itself. All right.
Okay, all right. Here is the one of the question that I am able to display here. The question is, what is the difference between the biological neural network and artificial neural network? The artificial neural network that is inspired from the biological neurons in our human brain. There's a cell, and we are trying to make such type of the node or such type of the neuron that is inspired from the human brain. If we're talking about the human brain cell, that in the human brain cell, there is the dendrites, there are the soma cell, there are the axon, there are the synaptic junction, there are the synapses. And if we are talking about the exact difference between the biological neuron that are the extremely slow as comparison to the artificial neuron, and the AN is extremely faster. And if we are talking about, if we are taking the example of we are playing a chess, that computer move are extremely fast, but the human moves will be slow for the correct move. And if we are talking about, if we are saying that in our brain, there is a large network of the interlinked neuron, which act as a highway for the information to the transmitting from point one to the point B, and it's a different kind of the information from A to B, and the brain activate as a different set of the neuron, and so the essential use of the different route to get from the A to B. And this is how the typical neurons look. If we are saying if we are go to the internet, and you have to look at the typical neurons, that you will find that there is the dendrite that is the receiver of the signal. After that, there is the cell body that is used for the that process the informations. After that, there is the terminal where is the network to the dendrites of the other neuron. If we're talking about the ANN, that is ANN is a model that is modeled after the biological neural network. And in the ANN model, that we have the input node, we have the output node. So the simple artificial neural network that map into the two scenario, which are the two different input, but with the same output, and we are applied the activations on that particular neuron. In the next, what are the type of the neural network? There are the different type of the neural network. We are using the convolutional neural network. We are using the recurrent neural network. We are using the backpropagation neural network. We are using the feed-forward neural network. We are using the recurrent neural network. So basically, we are using the generally three type of the neural network. That is the first one, that is the feed-forward neural network. Second one, that is the feedback neural network, and third one is the recurrent neural network. Is there any question?
I believe that's all. The people have these three questions itself, and I cannot see. So I believe we can close this session here. We can with the closure. Right. First of all, thanks everyone for joining the session, for attending this session, and thanks Professor Anurag for giving this insightful understanding about neural networks to us. Right. Talking about to the attendees, I'm sure you guys have learned a lot from today's session itself. You guys can bring it to the, obviously it is not possible for even Professor Anurag to explain entire neural network in just 30 minutes of session. Obviously it's not possible for anyone, right? So that is why we have programs related to, sorry. Yeah, Anurag,
Rohit, you well said, because neural network is a very vast subject, and we have the complete course in the neural network. And if you are talking about the history of the neural network, it will take more than 2 or 3 hours to discuss for the history, because it will start from the 1950s to till date.
Definitely. It is a very intriguing subject, of course, and obviously 30 minutes session do not do justice to it, right? So that is why we have a entire program on this particular subject, right? Mostly the students of computer science, artificial intelligence, data sciences are very familiar with it itself. I'm sure the attendees who are from the same background would understand better itself, but for those people who are just joining it for the first time and who are just beginning to learn, I can understand it might have been a very the session which is very heavy on you. Never mind, that is where the learning begins, right? Understanding certain things, putting an effort for certain things, that is where the learning begins. With that, we'll conclude the session. And the people who are interested in the program, my counselors are definitely going to get in touch with you. You guys, we have shared the details of FirstUniv as well, where you can directly call and reach out to our counselors as well. With that, very good evening. Have a grateful week ahead until we meet next time on next Friday at the same time with different session with very interesting subject, very different interesting subject. Once again, very grateful to you, Professor Anurag, for taking this session, right? And with that, we'll take a leave from all of you. Thank you, everyone. Thank you for being such a... I was saying thank you, Professor. Thank you for taking this session, and maybe we'll see you again probably in future sessions. And thank you.
Okay, thank you. Okay, bye.